Well, today when people are talking about the requirements, the capacity requirements for the backhaul networks for supporting LTE traffic, people are talking about something like 100 megabit per second per cell site, going up to several hundreds of megabit per second, up to, I would say, something like 1 gigabit per second. Today, our radio can support up to 1 gigabit per second. We can have all kind of compression. We have all kind of compression algorithm and also the adaptive modulation, which allows you to get much higher capacity over the radio by using the fact that in most of the time there is clear sky, there is no rain, so you can get much higher capacity by using very, very high modulation scheme with very high system gain. And this way you can get much higher capacity. This is one thing. And the other thing is using Ethernet, native Ethernet and native TDM. This way you don't need to have the overhead of encapsulation of TDM over Ethernet or vice versa. You can have everything run natively over the radio. This way you can save a lot of bandwidth in the backhaul. Well, there are different approaches for that. Some operators decided to build an Ethernet backhaul network in parallel to the old legacy TDM traffic and combine those two radios over the same antenna, something like that, which we can easily support. Some others decide to replace the old equipment with the new equipment that can today support the TDM traffic, but then can migrate very, very easily to a full Ethernet by the fact that you have both native Ethernet and native TDM side by side in the radio. You can today use the TDM, and as the Ethernet traffic becomes available or becomes needed, you can actually take part of the capacity and move it into the Ethernet into Ethernet, okay, native Ethernet, and then you can have both traffic run side by side. And later on, when you don't need the TDM traffic, you can have a full Ethernet. This is another approach.
I find that the hybrid approach is going to be around for some time because the transition period is going to be 5 to 10 years. You're going to have older base stations, 2G type base stations, 2.5G, 3G, and 4G. A lot of times coexisting with one another for a number of years. When you have that and you still have access to only a sliver of spectrum for backhaul, you need to use that piece of spectrum very efficiently. So it makes a lot of sense to have modern microwave technology to get lots of bits per hertz of efficiency, okay? And then combine TDM-based traffic and Ethernet-based traffic, okay? And in a very low latency manner, transport the signal, and then over time transition the TDM circuits over to Ethernet, okay, smoothly, okay, one by one as you retire the TDM-based equipment. We see that model working very well with most operators, especially in Latin America. And today, by the way, they don't need a lot of Ethernet. They need some, not a lot, because it's still, the world is mostly TDM. I mean, if you look at the base stations around the world, most of them are still TDM-based. But the new base station technologies are definitely Ethernet-based. And as you add those to the network, you need to transition them, right? And so you retire a little bit of TDM, you go over to the Ethernet base, and then over time, all of it would be transitioned. With our equipment, it's very smooth. So it's all done under software control, and it can be done remotely, in fact.
Yeah, I would, my opinion is that those things will continue as separate networks. There's a lot of existing equipment out in the field that's operational. Most of the time when you interact with the operators, their operating people, their operations departments don't want to touch or alter things that are working perfectly fine. Additionally, much of the lease line is leased, and those leases are typically long-term, low-cost leases, and so they don't expire conveniently when new equipment shows up. That sort of has to be faded in over time, and so you're going to see a gradual departure from TDM backhaul and a shift to Ethernet, but they'll be both operated simultaneously in the short and medium terms, in my opinion. VoIP and a number of other over IP applications, video over IP, gaming over IP, have very strict demands on network latency. To meet that requirement, all the constituent parts that are used to build up a network have to be engineered very carefully and participate in a solution which can support those applications. DragonWave spends a lot of energy in that area, making sure that our products interwork properly with leading switch manufacturers to deliver those latency and latency controlled transport networks so those applications run properly. Many of our customers also want us to build these interworking test networks up, and then they run the test services and applications on them to make sure that they work properly prior to their own field and pilot deployments. So it's a very it doesn't happen by accident. It's all very carefully engineered so that those services are properly supported to the maximum extent possible.
Yes, unlicensed spectrum is very useful when time to market is an issue. So it's a tool in the bag. So it's offered as part of our offering because a lot of times, even for microwave, you have to wait until you get the license and you have the site ready. And the antennas show up and all the things that you have to do. With license free, you can have same-day deployment. And that's really attractive. And the idea is that you have that in your tool bag. You can deploy microwave instantly, get the site up and running, get your subscribers on the network, and then at a later date, you can either bring new microwave, licensed microwave, in place of it and replace it, and then move that license-free microwave to another part of the network, by the way, usually around the edge of the network where the network is growing.
We do one unlicensed band, which is the 24 gigahertz. It's referred to as an ISM band. What we typically tell operators is if you want the link to work reliably and predictably, you can't use unlicensed spectrum because you don't have any idea whether it's going to be affected by interference in an hour, in a week, or whether the interference is going to be short-term or long-term. It may disable the network completely, which is a disaster for them. And we have done a lot of work, not so much recently, but in the earlier days where unlicensed backhaul was more popular, replacing networks which were built on unlicensed technology, which stopped working or stopped working properly. So we don't generally advocate it. However, most of those networks were backhauled on 5.8 gigahertz spectrum, which is also used for garage door openers and a myriad of other applications in virtually every country around the world. What we do sell is a 24 gigahertz product. It is also unlicensed, but that particular band is not typically, from a regulatory perspective, allowed to be used for anything else. It's used for very specific scientific and medical applications, and one of the allowed usages is a highly focused microwave backhaul.
Right, so at the edge of the network, the kind of numbers we're hearing right now is from 50 megabits all the way up to maybe 100, 150 megabits at the very edge of the network. Toward the middle mile part of the network, about 3 times that capacity, so about 300 megabits or so per second, and then you go all the way toward the core, which is gigabit capacity and beyond. Microwave actually plays very well in the edge of the network as well as the middle mile part of the network, all the way up to gigabit. In fact, with 70 and 80 gigahertz bands now becoming available in most parts of the world, the E bands effectively, you can get up to 10 gigabits per second through microwave. So it's very much fiber-like, if you will, right? So there's really no issues. Price points also have been coming down due to Moore's law. So now you can get a link of microwave radio for under $10,000 US list price for a complete link that has a couple hundred megabits of bandwidth capability. Which was unheard of if you go back a few years. So right now it makes it really compelling as compared to fiber. So before you dig up the ground, you really want to think twice about that.
So 80 gigahertz is new and unique, but that's not really what necessarily the unique aspect that Bridgewave brings to the table. We are unique in that 80 gigahertz is a new technology, and so because we've been in the market, we have a lot of experience in how to build a very robust, high-quality, high-performance system. And we've learned early on when we started working the technology in 2003, 2004, it's not an easy task, but we've gotten through that process and moved down the learning curve. So that is a benefit and value that we bring to the market. But not just that. We also have the highest throughput system on the market, so we can deliver 1.2 gigabits per second today. No other, and there are some other vendors that are doing 80 gigahertz. No other vendor can do that. We have the scalability to be able to do both simultaneous TDM as well as Ethernet. No other vendor can do that today. And we have the ability to scale from 100 megabits up to 2.4 gigabits with a software switch. So we have many capabilities there. And then last but not least, we have a carrier class platform that the operators require, and specifically that's the carrier Ethernet capabilities. It's flexibility in the tuning. We can tune anywhere in the spectrum. No other vendor that we're aware of can tune. And that's critical because as a vendor that has in a country or an operator in a country where the regulator specifies what channel you get, you need to be able to tune to be able to leverage what they give you. And